Good morning, students. Myself, Professor Uday Patel. Today we study about load resonant converters. In previous lecture, we discussed about what is resonance, what is resonance, what is need of resonant converters, and also discuss about the classification of a resonant converter. In that, the first classification is load resonant converter. Okay, we'll discuss about load resonant converters and also discuss about load resonant converter types like series loaded resonant converter, parallel loaded resonant converter, and hybrid resonant DC to DC converter. In upcoming lectures, we discuss about this three resonant converters. Now, now we quickly move forward to the our today's presentation or today's lecture, which is uh, the topic of load resonant converter. The load resonant converter consists of LC resonant tank circuit. What is LC? Uh, what is LC actually? This is inductor and this is capacitor. Okay, so we can say that the load resonant converter consists of inductor and capacitor component. Okay, but in which form? The resonant tank form. Tank form, it means what? Key, there's one and one circuit which consists of inductor and capacitor both, but in tank format. Okay, so we can say that the low resonant converter consists of LC resonant tank. Okay. After then, the oscillated oscillating voltage and current are applied to the load. Okay, and power flow to the load is controlled by a resonant tank impedance, which is turned to control the Fs. Fs means supply frequency. It means from this we can say that we have LC resonant tank circuit. It means we have uh, one sub circuit as a inductor and capacitor. Okay, which include the inductor and capacitor. Okay, and after then the oscillating voltage and current is applied to the load. Okay, because of what? uh, Harmonic contain or any other. Okay, we also provide the filtering element, so the oscillating voltage and current will be nullified. After then the power flow to the load. Okay, power is flowing from what? Supply to demand or supply to load. Okay, it is controlled by what? Our resonant tank impedance. Okay, Z. Okay, in that what happens? The Z is equal to XL plus XC. Okay, because we have inductor and capacitor. So by controlling this element, we can control the power flow from supply to the load. Okay. Now, now we move forward to the our first topic, which is series loaded resonant converter. Okay. First of all, we see the element of our circuit actually, series loaded resonant converter. In that, what happened? The first element is supply voltage. Supply voltage is DC voltage, and after then this is two equal rating of capacitor. So voltage across this capacitor is VD by 2, and also the voltage across is this capacitor. Let's consider this C1 and C2. So we can say that C1 is equal to C2 is equal to VD by 2. Okay, after this is T plus and T minus switches, you can use thyristor or IGBT or MOSFET, whatever you want, but depending upon your application. After this is D plus and D minus diode. Okay, this is used for positive half cycle. Sorry, positive half, not for positive half cycle, but this is for one mode and this is for other mode. Okay, this is LR and CR. Why we put this R in with inductor? Because this denotes as this is a resonant inductor and this is a resonant capacitor. Okay, current through the inductor is IL and voltage across CR. It means capacitor across resonant capacitor across voltage is VC. Okay, after this is four diode which converts the AC into DC into AC, or what it is called as bridge circuit. Okay, after this is capacitor again, but it is filtering capacitor because power is and power or voltage and current is oxidating. So this capacitor is used for what? Nullify or reduce the oxidation. So and finally this is resistor, or we can say that this is load, our load. So our load is a resistive load. Okay, the equivalent circuit of this main circuit is this. Okay, this is our equivalent circuit. Okay, now and this is our mode for IL is greater than 0 and IL is less than 0. Okay, if we're talking about our first mode or first case, then the inductor current, okay, is greater than 0. So wait a minute, like if this capacitor is distributed or distribute its energy to our main circuit, then the current is flowing from this direction. Okay, consider this as current flowing through VD by 2, this VD by 2 actually. After then, if you give the uh, base or control signal to T plus, then current is flowing from this T plus, and then from A point, it will further flowing through this tank circuit. Initially, the inductor and capacitor in discharge condition, so no energy is stored in the inductor and capacitor. After then, current is flowing uh, through these diode. Okay, after then, this is further current is flowing through in this direction. Okay, and also this direction. Okay, consider this current flowing through this, because if current is flowing through this and current is flowing through this, the voltage across uh, the CF or R will be same, because the both elements are in parallel condition. Okay, after then the current flowing through this diode, and finally the current flowing to this direction to complete its closed loop path. Okay, so if you consider this current flow, then the inductor and capacitor will be charged to up to its what? Up to its maximum value or rated value. Okay, and the energy is also supplied to our resistor or load. So the filtering capacitor is used for what? The reduce the harmonic current content from voltage and current. Okay, so got we will get the harmonic free energy. Okay, now okay. After then, what happen if the energy is fully what if the tank circuit is charged up to its rated value? After then, what happens? Okay, first of all, we discuss this. Okay, if T plus is conducting, voltage across VAB is equal to half VD. Okay, where is this, A is this. Okay, voltage across this point and this point is half VD because this is VD by 2. Okay, of course, you if we use the if you measure the voltage across this, so the voltage across this what? This VAB. So definitely we got the voltage across VAB is equal to VD by 2. Okay. Also this voltage is applied to this capacitor also or load also. So we got the VAB is equal to positive VD by 2. Okay, and VAB dash is equal to what? Okay, simply you have to apply the KVL. So minus of VD by 2, sorry, minus minus plus Vd by 2. Okay, if you consider the current flow in clockwise direction, so the positive Vd by 2, Vab dash, okay, minus of V0. This V0 is applied to also resistor, okay, and after then it is equal to 0. So we got AB dash is equal to positive Vd by 2 minus of V0. Okay. Now, if we let me okay. Now, now if IL is greater than 0 means what? The current inductor current is greater than 0. So when the inductor is discharged, okay, at that time what happens? The discharge current is flowing same direction as the charging direction. Okay, so the current is flowing through this inductor is same direction as before. So current is flowing through this. Okay, but at that time what happened? D minus is conducting. So this manner, this closed loop path will be or completed. In this manner, we got VAB is equal to minus of VD because our VAB is this and this. In this point, the resonant tank work as what? As a source. Okay. Before, this is source and this is sink. Okay. This both are work as sink. But after then, the main source as a inductor. Okay. And the sink is resistor. Okay. So the polarity of this inductor is positive and this is negative. Okay, because current is flowing from what? Positive to negative, not negative to positive. So the voltage across the V A B is equal to what? Minus of V D by 2. Okay, so we got minus of V D by 2. Similarly, if we apply the KVL in this circuit, okay, we will get the VAB dash is equal to minus of 1 by 2 VD minus of V0. Okay. After then, if you consider this if you give the signal to T minus, then T minus is conducted, and if you consider the current flow, okay, after then you will get the VAB is equal to minus of 1 by 2 VD by 2, and similarly VAB dash is equal to minus of 1 by 2 VD plus V0. Okay, similarly in discharging time, the D minus conducting, this D minus sorry, D plus is conducting. Okay, and at that time we got VAB is equal to positive VD by 2, and VAB dash is equal to positive VD by 2 plus V0. Okay, this is very easy. Okay, so this is our series loaded resonant converter. After then, if you talking about the parallel loaded resonant converter, that what happened? The inductor is same. Okay, it is in series with our main load, but the capacitor is paired with load as well as our supply. Okay, so this VD by 2 is directly uh, across the this capacitor, and capacitor is directly across this resistor. So equivalent circuit is given in this manner. Okay. So in that what happen if T plus is conducting? So now we will through the current flow through the VD by 2 T plus inductor, this diode, after then this filtering inductor, okay, a resistor, okay, this diode, okay, after then again B point, okay, after then this current is flowing through this, and finally it is completed its path. Okay, current is also flowing through this filtering capacitor. Nothing changed. Okay, so in that what happens, the V voltage across A point and B point is positive VD. Okay, and after then if T minus is conducting, and at that what happen, wait a minute, I will change the color. Okay, if VD this VD supplied the energy at that time. Okay, this is not joint. Okay, so current is flowing through this in this direction. Okay, now this diode, okay, similarly this, okay, at that time T minus is conducting and this is complete the closed loop path. Okay, at that time the VAB is equal to minus 1 by 2 VD. Okay, this is very simple. Okay, in discharging time in our first mode, D plus is conducted. Okay, at that time same VAB voltage is equal to positive VD by 2, and in the T minus conducted time, okay, the in discharging time the voltage across the VAB is equal to 1 by 2 VD. Okay, this is parallel loaded resonant converter. Okay, now there is some important notes for parallel loaded resonant converter and series loaded resonant converter. We discuss about the series as well as parallel loaded resonant converter. If we differentiate or separate out some by some point, okay, the first point is parallel loaded resonant converter appear as a voltage source. Okay, because in discharging time this capacitor working as what, as a source. Unlike the series loaded resonant converter, parallel loaded resonant converters do not possess inherent short circuit protection capability. Okay, what it means that in parallel loaded resonant converter there is short circuit security, okay, or protection. Okay, but in series loaded resonant converter, if the fault as short circuit, then there is no protection capability provided in the series loaded resonant converter. Okay, it is obviously drawback of SLR. Okay, PLR, it means parallel loaded resonant converter can be step up as well as step down the voltage, unlike the series loaded resonant converter which can operate only step down converter. Okay, if you uh, consider the step up and step down converter, okay, there is same configuration is provided in this PLR and SLR respectively. Okay, so in the last, this is hybrid mm, resonant DC to DC converter. Okay, in that this is main supply voltage VD. Okay, this is capacitor used for constant uh, voltage applied to the main circuit. This is CR1 and CR2. Okay, this is LR and this is CR2. Okay, this is two switches provided in the circuit. Okay, you can use the thyristor IGBT MOSFET whatever you want. After then this is two diodes. Okay, uh, and there is one midpoint transformer provided in this circuit. Why we required this kind of transformer? Because it isolates the uh, primary to secondary circuit. Okay, or you can say that it is isolate the supply and demand. Okay, so no effect will be uh, created or produced by this primary to secondary circuit. Okay, this is filtering element, inductor and capacitor, and this load. Okay, the working will be same if uh, like I only show the current flow for this. Okay, okay, after this current is flowing through this. Okay, easy. Okay, if this capacitor is At that time, this switch will be on and current is flowing through in this manner. Okay, both the time will be got positive V0. Okay, so this is hybrid resonant DC to DC converter. Okay, why we require hybrid resonant DC to DC converter if we have the parallel and series resonant converters? Because in series resonant converter there is some advantages of it converter, like some filtering element or any other advantage, and in parallel resonant converter it it has the short circuit capability. So we merge both the advantages. If we want to merge both the benefit in one circuit, so we should create the one other one new converter, which is hybrid resonant DC to DC converter. So we can use the both the capability of the converter. So this is hybrid resonant DC to DC converter. After then, this is resonant switch converter. We will discuss about the resonant switch converter in our next lecture. Thank you so much.